distance of the balance point from zero end if the body were moved to 13 cm mark. A body is hung in a metal rule 6 cm from one side of the metal rule, and the weight of the metal rule balance 30 cm. Then, if the distance from where the weight of the metal rule balance to the weight of the actual weight of the metal rule is 18 cm, then we now observe that the distance from the pivot of the balance is 30 cm, and the distance from the weight of the metal rule to the weight of the tip of the metal rule is 48 cm, and the remaining 52 cm is gotten by minusing 48 from 52. Figure 1.2 example. Let the mass of the rule be represented by W, taking the moment about the pivot 60 gram times 30 minus 6, which is 24, is equal to W, which is 48 minus 30. 60 times 24 is equals to 18W. Making W the subject of the formula, we have that W is equals to, in brackets, 60 times 24 all over 18, which is 80 gram. Looking at this diagram, a metal rule of 100 cm and 60 gram is hung from the tip of the metal rule at a distance of 13 cm from the tip of the metal rule and 13 cm from the pivot. And another weight is hung 48 cm. 80 gram of weight is hung 48 cm from the pivot of from the tip of the metal rule. In example, let the distance of the new balance point be x from zero end, taking the moment about the fulcrum. (60) in bracket x minus 13 close bracket equal to 80 in bracket 48 minus x. Dividing both sides by 20, we have 3 in bracket x minus 13 equals to 4 in bracket 48 minus x. 3 times x is minus 39 is equals to 192 minus 44x. Bringing like terms together and unlike, we have that 3x plus 4x is equals to 192 plus 39. 7s is now equals to 231. Making s the subject of the formula, you have 231 over 33 cm. Example 2. In the diagram below, what is the value of W? Figure 129 example shows a metal rule hanged 1 meter from the fulcrum. The weight of the tension on the metal rule is 20 Newton. The weight of the metal rule is hanged 1 meter from where the metal rule is hanged, and the rest of the metal rule is 1 meter. We are asked to find the value of W, which is the weight of the metal rule. Solution. Taking the moment about x, sum of clockwise moment equal to sum of anticlockwise moment. Weight of the meter roll is pulling the meter roll downwards. That to show that it is at a clockwise moment. So the weight of the meter roll times the distance from the fulcrum, which is 2, which is equal to the anticlockwise moment. Since the meter is being pulled by a tension of 20 Newton and is times by the distance from where the fulcrum is, which is 1. Then making the weight W the subject of the formula, we have that 20 over 2 is equals to 10. That is the weight of the meter roll. Example 3. Figure 130. A uniform beam HK of length 10 meter and weighing 200 Newton is supported at both ends. A man weighing 1000 Newton stands at a point P on the beam. If the reaction at H and K were respectively 800 Newton and 400 Newton, calculate the distance HP. Solution. Figure 131 shows a uniform beam of 10 meters HK weighing 200 Newton at a point O. If the fulcrum reactions are respectively 800 at H and 400 at K, and the man having 1000 Newton weight at P, we are asked to get the distance from H to P, which is X. Then taking moment about H, clockwise moment is equal to anticlockwise moment. Since the reaction is acting upwards, therefore 4 times 10, which is the length, 400 Newton of the reaction at K, times 10, that is the distance, the length of the meter roll, is equals to, since the weight of the meter roll is 200 and the half of it is now 5 meters, therefore 200 times 5 plus 1000, which is the position where the man is, times X, which is what we are looking for. 100x, collecting like terms together, making, we have that 100s is equals to 4000 minus 1000. Then making x the subject of the formula, we have 3000 over 1000, which will give us 3 meters. Example 4. A non-uniform rod XY of mass 40 kg and length 5.0 meters lies on horizontal ground. Its center of gravity is 2.0 meters from the end X. Calculate the vertical force P that will be sufficient to lift the end Y from the ground. Why would the force P, if applied at the end X, not be sufficient to lift the end X from the ground? Take G equals to minus 10 meters per second.